Hello guys, welcome once more to class online. My name is Tutor Dami, and in this edition, if you ever have a problem on mirror, then this might be the video that will solve most of your problem in mirror, because in this section we have almost the questions Jamb Physics 2012 question number 31 to 35 on mirror. So it really helps us to see a lot about mirror, and it will help us to clarify a lot to you about answering Jamb questions in mirror. Now let's get to the heart of it. Don't forget that if you learn something from this wow, that's the plane. Okay, so don't forget that if you learn something from this video and you want to get more content from us that will better help you understand physics, click on like button. We have a lot to share with you that will clarify so much to you in physics. Let's get to number 31. It says a pinhole camera placed 300 meters in front of a building so that the image is formed on a screen 5 centimeters from the pinhole. If the image is 2.5 centimeters high, the height of the building will be what? Now, this is an interplay between distance and height, right? And whenever you have a question talking about distance and height, what you have to do is the magnification formula. Height of image is equals over height of object equals distance of image over distance of object. This is the way to go on any question that mentions distance and height. Just say the height of image over the height of the object equals the distance of image over the distance of object. This is the magnification formula for mirror. Please don't forget. Therefore, what's the height of the image? In the question is 2.5 centimeters. Over what is the height of the object? We are told to find the height of the building, and that is the object. Okay, equals what is the distance, distance of image is 5 centimeters. Over what is the distance of the object is 300 meters, and that is the way to go about solving it. Please take note that some of them are in meter while some of them are in centimeter. Both of the object height and distance are in meter, but the image the image height and distance are in centimeter. So we have to find the object height. We'll just say we'll cross multiply here. That will become 5HO equals 300 times 2.5, and that will give me 5HO equals 750. Divided by 5, I'll be getting my object height as 150 meters, and that is the simple answer to the simple question. So that settles that question. Don't forget that I said if you are given a mirror question that is speaking of distance and height, this is the formula: height of image over height of object equals distance of image over distance of object, and that will take you to your answer straight. So the answer for number 31 is D, and that is it. Full stop. Let's see number 32 says the magnification of an object of an object 2 centimeters tall when placed 10 centimeters in front of a plane mirror is what? Now this question is asking for magnification, but it gave you an object height and it gave you the distance of the object. Now, what do you think that we will do? Now, but it also said that a plane mirror. Okay, now when I first saw this question, I was a little bit shocked because you are supposed to give me object and image, but they gave me object and object height and object distance. It is not making any sense. But however, at a closer look, they spoke about plane mirror. It is a plane mirror question. That means it doesn't matter it doesn't matter the object height, it doesn't matter the object distance, as far as it is a plane mirror. It is not a convex mirror, it's not a concave mirror, it is just an ordinary mirror. That's a plane mirror. And you can see the mirror. This is a plane mirror. In the house of Mr. Tijani, I went to his house and snapped that mirror, and that is his house. You can see his room is very, very fine. Now, this is a plane mirror, right? Ordinary mirror, right? Now, for any plane mirror, it doesn't matter the height of the object or the distance of the object. It is the same answer for the magnification. The plane mirror produces images that have a magnification of 1. So if it's a plane mirror, the magnification does not change. It is a trap. Okay, it is just 1. Every ordinary mirror does not change magnification. That's if you stand before an ordinary mirror, you are actually the same height. Like if I'm looking at myself before an ordinary mirror, a plane mirror, I am just the way I am. Okay, I don't get bigger magnification, I don't get bigger or smaller. I am just the same way. So the magnification for all plane mirror is just 1, and that is just the answer. The answer is just 1. Now this is, somebody might be saying, but we are given 2 centimeter tall object, and we are given that the distance is 10 centimeter, and so on. Those are just jargons. Those are just traps for you. As far as it's a plane mirror, the magnification is 1. Number 33 says, after reflecting from the concave mirror, rays of sunlight from the rays of light from the sun converges where? Now, if you put a concave mirror in the sun, you know what will happen, right? It converges where? The answer is very simple. Now, look at this now. If you put the sun, now this is the sun ray coming in. It's coming into the concave mirror, but it will now go this way. This is a concave mirror. It will converge where? It's converging where? You can see where it's converging now. It's converging at what? At what? At the focus. It will convert. It is coming in. This is the real sun coming in. But where did it convert? It will convert because it is a converging mirror. It converges the ray. It converges the ray. So it will converge where? At the focus. And that is the answer. For a concave mirror, all the ray will converge at the focus. Now, if it were a convex mirror, it will diverge, it will spread out. But if it is a concave mirror, it will converge at the focus, and that is the answer. It will converge at the focus. If you're looking at this drawing, you can see that already the sun rays coming in, but when it strikes this thing, now these parallel rays are the sun ray coming in. But when it strikes the concave mirror, it will go to the center. It will convert, all the rays will converge at the F, at the focus, and that is the answer. It converges at the focus of the mirror. Now, number 34 says a glass block of thickness 10 centimeters is placed on an object. Okay, if an observer views the object vertically, the displacement of the object is what? Now, the glass index is 1.5. Now, when you hear the word thickness, any mirror question with thickness has only one formula. And please get used to the formula. Anything on thickness will use this simple formula, and that is this: position is equals to thickness bracket 1 minus 1 over glass index, the mirror index. Okay, now what is the thickness in the question? 10 centimeters, so that's 10, T is 10, plus bracket 1 minus 1 over, what is the refractive index of glass? 1.5, and that's it. Now plug it on, put all in, then we will find the displacement of the glass. Okay, so let's see what is the displacement of the image of the object. Now, what is the object displacement? That will become 10. 10 is still 10. 1 minus 1 over 1.5 is 0.67. 1 minus 0.67 is 0.33 times 10, and that becomes 3.33. So the master formula for finding displacement, P, it means displacement. Displacement of an object when you are given the thickness is T bracket 1 minus 1 over refractive index. Please take note. For any mirror question, when you are given the thickness and you are told to find the displacement is T bracket 1 minus 1 over glass index, and that is the answer for the question number 34. Now it is A, 3.33 centimeter. Number 35 says a ray of light traveling from a less dense medium to a denser medium. The angle of incidence is greater than the critical angle. Ray of light traveling from a denser medium to less dense medium. Which of the statements above are conditions for total internal reflection to occur? Now, when you hear total internal reflection, it is reflection within the same medium, but it is actually a reflection that occurs when you are inside the swimming pool and you look at the top of the water. You are inside the pool and you look at the top of the water, then you can see the bottom of the pool reflecting while you are looking up. Okay, now you know when you are swimming inside the swimming pool and you look up the water, you can see a reflection of the lower part of the water, right? That is called total internal reflection. But for you to have that experience, some things must occur. One of such is what? They are now asking now, what are the conditions? The ray of light travel from a less dense medium to a denser medium. That is actually not true. So number one is not true, because you are in the pool. It must be traveling from your eyes, that means from a denser medium to the air. So you are inside the water. What I mean is that when somebody is in, like if this is the pool now, the ray of light is coming from where? Inside the water, that's the glass. Okay, going towards air, right? So it must be traveling from a denser or thicker medium like glass to a less dense medium like air. So it must be coming from a denser medium, and it must not go to the air, but it will now go down to the same medium. So if I am the one swimming in this glass or in this water now, I am looking at the water surface now from under the water. A reflection of the water will occur, and I will be able to see the bottom of the water from inside the water, and that is just it. Now that is the condition for total entire reflection to occur. It must be moving from a denser medium like water to a less dense medium like air. And number two condition is the second thing here. The angle of incidence must be greater than the critical angle. That means the angle of incidence must be greater than the critical angle, and that's what we have here. Critical angle is an incident angle whose refractive angle is 90 degrees. Now in this case, the angle of incidence must be more than 90, and that's what I have here. You know that this is, if I draw a straight line here, if I draw a normal here, from here to the normal here is 90. But the angle from the incident here is more than 90. You can see from here to here is more than 90. The angle here is more than 90. So, and that is the second condition. The angle created must be more than 90 degrees. The angle of incidence must be more than the critical angle, which refractive index is 90 degrees, and that is the answer. So the two conditions are, it must be going from a thicker or denser medium like water or glass here to a less dense medium like air, number one. Then number two, the angle created by the incident angle must be more than the critical angle, which is the angle whose refractive index is 90 degrees, and that is the answer to that question. So the only true options are option 2. The angle of incidence is greater than critical angle, number one. Then the ray of light must be traveling from a denser medium to a less dense medium. So the answer is 2 and 3, and that means option C, the correct answer to that question, option C. And that brings us to the end of this video. Maybe at a later time we might treat more of reflection as a topic on its own, but for now that is the answer for number 35. And that brings us to the end of this video. Don't forget that if you learn something from this series and you want to get more content from us that will better help you understand physics, click on like button and we'll get to reach you with more content that will clarify so much to you in physics. Until we see you again, guys, take care of yourself and bye for now.